Welcome back. Now let's do a problem that involves almost everything we've learned so far about probability and combinations and conditional probability. So let's say I have a bag again, and in that bag I have 5 fair coins, 5 fair, and I have 10 unfair coins, 10 unfair. And a fair coin, of course, there's a 50-50 chance of getting heads or tails. And the unfair coin, let's say that there is a 80% chance of getting a heads for any one of those coins, and that there is a 20% chance of getting tails, right? Because it's going to either be heads or tails. So my question is what happens is I put my hand in the bag, and my eyes are closed, and I picked out a coin, and then I flip it 6 times. And it turns out that I got 5 out of, well, let's say, let's say I got 4 out of 6 heads. That's the result I got. What I want to know is, what is the probability that I picked out a fair coin given that I got 4 out of 6 heads? So before moving on, let's do a little bit of a review of Bayes' theorem, and I think that'll give us a good framework for the rest of this problem. So Bayes' theorem, and let me do it in this corner up here. Bayes' theorem tells us the probability of both A and B happening. That upside down U is just intersection in set theory, but it's essentially saying, it's the set of events in which both A and B occur. That's equal to the probability of A occurring given B times the probability of B, which is also equal to the probability of B occurring given A times the probability of A. And I think this should make some intuition for you. If it doesn't, it might be a good idea to watch the conditional probability videos. But what we can do is we can rearrange this equation right here to get, if we just divide both sides by the probability of B, we get the probability, and I'll do this in a vibrant color, the probability of A given B is equal to the probability of B given A times the probability of A divided by the probability of B. I just took this equation, divided both sides by the probability of B, and I got this. So what is A and B in the problem we're trying to figure out? We want to try to figure out the probability that I picked out a fair coin given that I got 4 out of 6 heads. So in this situation, A is that I got a fair coin. A is equal to picked fair coin, picked fair. And then B is equal to 4 out of 6 heads. 4 out of 6 heads. So in order to figure out the probability that I picked a fair coin given that I got 4 out of 6 heads, I have to know the probability of getting 4 out of 6 heads given that I picked the fair coin times the probability of picking out a fair coin divided by the probability of getting 4 out of 6 heads in general. So this is probably the hardest part to figure out, and we will, along the way, we'll actually probably figure out the top 2 terms. So what's the probability of B, or the probability of getting 4 out of 6 heads? Let's see what happens. Right when I put my hand into the bag and I pick out a coin, there is a 5 in 10 chance, or 5 in 15 chance, right? There are 15 total coins, that I pick a fair coin. So 5 in 15, that's the same thing as 1/3, that I pick a fair coin. And then there's a 2/3 chance that I pick a unfair coin, right? Now if I pick a fair coin, given that I have a fair coin, what is the probability? What is the probability, given the fair coin, what is the probability that I get 4 out of 6 heads? Well, once again, let's think about the previous several videos. What's the probability of getting any one particular combination of 4 out of 6 heads? So for example, it could be heads, tails, heads, tails, heads, heads. It could be I don't know, it could be the first 4 heads, 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 tails, tails, right? And there are a bunch of these, and once again, we'll use the binomial coefficient, or we'll use our knowledge of combinations to figure out how many different combinations there are. But what's the probability of each of these combinations? Well, what's the probability of heads? That's 0.5 times 0.5 times 0.5 times 0.5. And then the probability of tails, since it's a fair coin, is also 0.5 times 0.5 times 0.5. So each of these There's a 1/2 chance of getting a heads times a 1/2 chance of a tails times 1/2 chance of a heads times 1/2 chance of a tails, etc., etc. So each of these are essentially 1/2 times 1/2 6 times. So the probability of each of the combinations is 1/2 to the 6th power. 1/2 to the 6th power. And so how many combinations are there like this, where you get out of the 6 flips you're essentially choosing 4 heads. You're choosing, if I'm once again the god of probability, I am picking exactly 4 of the 6 heads. I'm picking 4 of exactly 6 of the flips to end up heads, right? I'm choosing which of the flips get selected, so to speak. So it's essentially there are going to be out of 6 flips, I'm choosing as the god of probability 4 to be heads. So that's the number of combinations, the number of unique combinations where you have 4 out of 6 heads, times the probability of each of the combinations, which is 1/2 to the 6th power. Well, what's 6 choose 4? That's 6 factorial over 4 factorial times 6 minus 4 factorial, so that's 2 factorial. And that's times 1/2 to the 6th. And I'll switch colors again just to stop the monotony. And that equals, let's see, 6 times 5 times 4 times 3 times 2. We don't have to write the 1 times 1. Well, I'll do it anyway. Over 4 factorial, 4 times 3 times 2 times 1. And then 2 factorial, 2 times 1. So that cancels with that. The 1 we can ignore. 2 divide both sides by the numerator and denominator by 2, and this becomes a 3. So this becomes 15. So this equals 15 times 1/2 to the 6. So what's 1/2 to the 6? That's 1 over 64, right? So 1 over 64, so it becomes 15 over 64. So the probability of getting 4 out of 6 heads given a fair coin is 15 out of 64. So this is the probability of 4 out of 6 heads given a fair coin. And if you look at it, based on our definition of B and A, this is the probability of B given A. Right? B is 4 out of 6 heads given a fair coin. Fair enough. So let's figure out the probability of, because there's 2 ways of getting 4 out of 6 heads. One that we picked a fair coin, and then times 15 out of 64, and then there's a probability that we picked an unfair coin. So what's the probability of the unfair coin? Of getting 4 out of 6 heads given the unfair coin? Well, once again, what's the probability of each of the combinations where you get 4 out of 6? So in this situation, let's do the same one. Heads, tails, heads, tails, heads, heads. Right? That's 4 out of 6 heads. But in this situation, it's not a 50% chance of getting heads, it's 80%. So it would be 0.8 times 0.2 times 0.8 times 0.2 times 0.8 times 0.8. And essentially we have, this multiplication, we can rearrange it because it doesn't matter what order you multiply things in. So it's 0.8 to the 4th power times 0.2 squared, right? And it doesn't matter, any of the unique combinations will each have the same probability because we can just rearrange the order in which we multiply, right? And then how many of these combinations are there? If we are once again the god of probability, and out of 6 flips we are picking 4, we're choosing 4 that are going to end up heads. How many ways can I pick a group of 4? Well, once again, that's times 6 choose 4, and we figured out what that is. 6 choose 4 is 15. So this equals 15 times 0.8 to the 4th times 0.2 squared. So the probability, so this is the probability of 4 out of 6 heads given an unfair coin. So what's the total probability of getting 4 out of 6 heads? Well, it's going to be the probability of getting the fair coin, which is 1/3, times the probability of getting 4 out of 6 heads given the fair coin, and that's this, 15 over 64, times 15 over 64, plus the probability of getting an unfair coin, 2/3, times the probability of getting 4 out of 6 heads given the unfair coin. And that's what we figured out here. times 15 times 0.8 to the fourth times 0.2 squared. And this is the probability of getting 4 out of 6 heads. And let's figure out what that is. Well, this will cancel out with this. This becomes 5 out of 64. That's easy enough. 2/3 times 15, that's 10. And now we just have to figure out what that is. Let's see. I'm going to go over the time limit to see if being a YouTube partner allows me to go over the time limit. Let's see. 0.8 times 0.8 times 0.8 times 0.8 is equal to, and then times 0.2 squared, so times 0.2 times 0.2 is equal to 0.016, so that's that. And then we say times 10, right, because 2/3 times 15. So times 10 is equal to 16.384%. So the probability is, so this term right here, let me write that down, and I'll switch colors again. This is 0.16384, and we're going to add that to 5 divided by 64. So let's see. 5 divided by 64 is equal to 0.07, whatever, plus 0.16384 is equal to 0.241965. So that's the probability, not knowing which coin I picked out. That's the probability of getting 4 out of 6 heads. When you combine it, it could be 1/3 chance fair, 2/3 chance unfair. So that's 24.19. I'm keeping the precision just because it might come in useful later. % chance. So that's the probability of B. So let's see if we can clean this up a little bit, just because I don't think we need all of this writing now. I think we're ready to substitute into our Bayes formula, Bayes theorem that we rederived. Let me derive. Nope, that's not what I wanted to do. Recording longer videos is dangerous because if I make a mistake, that's more time wasted. I don't want to delete anything that could be useful. Okay, so let's see if we can solve the probability that we picked a fair coin given that we got 4 out of 6 heads. So that is going to be equal to, by Bayes' theorem, which should make some sense to you, that is equal to the probability of B given A. So it's the probability that we get 4 out of 6 heads given a fair coin times the probability of a fair coin over the probability of getting 4 out of 6 heads either way. 4 out of 6 heads. So 4 out of 6 heads given a fair coin, we figured that over here. That's 15 over 64. So this equals 15 over 64. What's the probability that we picked a fair coin? Well, there's 15 coins, and 5 of them are fair, so it's 5 out of 15, so it's 1/3. So times 1/3. And what's the probability that in general we picked 4 out of 6 heads? Well, that's this number, 0.241965. So this equals, let's see, this is equal to 5 over 64 divided by 0.241965. And what is that equal to? That's 5 divided by 64 is equal to that, divided by 0.241965 is equal to 32 point, well, roughly 3%, is equal to 32.3%. So that's amazing, or relatively amazing. It's a little bit less than a 1/3 shot that we picked the fair coin, given that we got 4 out of 6 heads. And what's interesting is the 4 out of 6 heads, it kind of decreased the probability that we got a fair coin, right? Because of before having any data on what happens when we flip it, we would have had a 1/3 probability, which is 33.3, right? But given that we got more heads than tails, kind of the universe of probability is telling us that, well, if you got more heads than tails, that makes it a little bit more likely that you pick the unfair coin, which is a little bit more weighted to heads. But it's saying it's not that much more likely because this isn't that unusual of a result to get even with a fair coin. And so that's why it became a little bit less likely to get a fair coin. I will actually, and let me give you a Let me give you a bit of an intuition visually, kind of with set theory, on why that makes sense. Why that makes sense. So if we go back to Bayes' theorem, let's just say that, this is this is the universe of all of the events, right? That's all of the universe. There's roughly a 1/3 chance that I picked a fair coin, so roughly 1/3 of this will be fair. So this is fair, this is unfair, right? And then if I picked a fair coin, we figured out that there's roughly a 15 out of 64 shot that I get 4 out of 6 heads. So maybe that's this little section of the, let me do it in a different color. That's this section. And then we figured out if we have an unfair coin, I forgot what the exact number is, but there was some probability that we get 4 out of 6 heads, right? It's actually a little bit bigger. It's like that, right? So this is getting 4 out of 6 heads given you got an unfair coin. This is getting 4 out of 6 heads given that you got a fair coin. And then this whole area is a probability that you get 4 out of 6 heads. So all Bayes' theorem told us is, look, we got 4 out of 6 heads. So we're in this universe where we got 4 out of 6 heads. And if we got 4 out of 6 heads, 1/3 of this universe, roughly, or 32.3% of this subset of 4 out of 6 heads, intersects with the fair coin universe, right? So this 32.3% is essentially this fraction of the total probability of getting 4 out of 6 heads. Anyway, hopefully that gave you a little bit of intuition, and I hope that YouTube lets me publish this video because I'm on my 17th minute. I'll see you in the next video.